interview, that's right. Yeah. Okay, anyways, last time when everybody was asleep on Wednesday morning, where were you, Albert?
Yeah, I did.
Yeah?
I am there.
Are you sure?
Yeah, I have the notes.
Okay, I believe you. Where were you, John Ray? Yeah. Now I think John Ray and where were you, Leon, yesterday?
Okay.
Yeah, sleep, huh? John Ray and Leon, I'm going to need to talk to Connell because you are missing many of my 9 o'clock classes on Wednesday, and it's becoming a problem. Okay, so you have Connell individual tutorial this week? You had it already? Yeah. So he might want to talk to you now about your Wednesday 9 o'clock. You don't have it this week, you'll have it next week, is it?
Right.
Connell's your tutor, isn't he?
Yeah.
Yeah. And you have tutorial with him, yeah? Yeah. It's tomorrow, yes, so that's this week, so don't make it difficult for me. Wednesday 9 o'clock is a problem for you, and it's a problem for you, and it's okay for you at the moment, Albert, but just be careful. Be careful. Yeah? Okay. Anyways, I'll explain quickly what we did last time, okay? So last time, I know you were in the class before the last class. We had data like this. What was this graph called? Scatter plot. So we draw the line, and you remember, for example, we calculated the slope by measuring the line. And also you should remember that we always pass through the average of the x and the y, always. Remember this? Yeah. What we did last class, wait, listen, now this is important for your assignment. Listen. If you missed the class yesterday, you must watch the video, and I will check to see if you watched it, okay? So right now it probably has one view from when you watched it, okay? So I want you to watch the video later, because your assignment is about what we did in the last class, and it's about this new class today as well, okay? No, you're going to watch it. Because you're doing that thing where you're like, yes, teacher, I will watch it. And I know you're thinking, no, I won't watch it. I want you to watch it later today.
Oh, for the weekend.
No, later today.
Because we have no.
I want you to watch it later today.
Oh.
Yes, thank you. Okay? I don't care if you watch it on your phone, on the bus. I want you to watch it today, at some point today. Yes? Okay. It's important for your assignment. Now, what we looked at last time on Wednesday was the formula for this line, y equals ax plus b. And I actually gave you a formula to calculate the a and to calculate the b. So the formula for the a, it's actually on the back, on the very back page. The formula for a is n sxy minus sxsy over n sxx sxsx, and then b was sy over n minus a sx over n. And what you might not know is what the s stands for. So sx is the sum of the x's, sy is the sum of the y's, and then sxy, sums of the x's and the y's, sxx, sum of the x by the x, so x squared then. Yeah. So just as a little bit of a revision, we'll do a quick example, and then I'll let you try one, then we can have a look at any problems, then we can start the new lesson. So, the reason I was saying this is related to your assignment is because in your assignment you're going to have to find two data sets that you believe have a relationship. So I gave you some kind of simple ideas like price of a Big Mac and the salary income for the country, you know, or inflation and interest rate, or inflation and unemployment, or I think you're doing with Donald balance of trade or something. Yeah, balance of trade. So Donald, when I was talking to him, said that exchange rate and exports should be related. So if your exchange rate increases, it gets stronger. Did you learn what happens to your exports?
Not yet.
Not yet. Okay, so I'll ruin the surprise for you. If your exchange rate increases and your currency becomes stronger, then your exports, anyone know? Decreases, yeah. If your currency becomes weaker and your exchange rate drops, then your exports will increase. So countries with a strong exchange rate should have a lower export, and countries with a weak exchange rate should have a higher export. So for example, China has a very high export rate because its currency is quite weak, and its currency is quite weak because the government forces it weak. A country like United States is very exceptional, special case. Don't consider that one. Another country like, I don't know, what would have low export? Well, I guess, yeah, United States. United States will have low exports compared to maybe other countries of its size because its currency is quite strong. I think United States imports a lot more than it exports. Yeah. Anyways, there's a few ideas that you could have for your project, and if you want, I recommend that you talk to Donal if you want some ideas for what you could study. Okay? And if you have an idea, I have one example. It can be anything. One example from last year I thought was interesting. I was telling Marcelo about it, was how much the football player gets paid and how many goals they scored. You think more pay should mean more goals? You would think, okay? So whatever you can imagine, you can do.
But excuse me?
Yeah.
How are we going to collect the data?
Yeah, you have to find it online. So I can give you the name of some websites.
Economics? Or?
Yeah, it can be like economics website, government statistics website. But I don't really mind what the source is, you know, as long as it's not somebody's blog. I don't mind, yeah. So if you find some website with some numbers, data on it, that's fine, okay? Right, so let's put in some examples here. So we have X, and we'll have Y. So we'll put in X, we'll go X is 0, 1, 2, 3, 4, and then Y we'll make it 1, and then, well, let's make it 0. And then here we'll make it 3, and here we'll make it 4, and here we'll make it 7, and here we'll make it 8, something like that. Okay, let me make that a little bit bigger for you. Okay, so this is our data. Please write that down. Got that? Yep. Alright, so let me show you this one as an example. So firstly, we need to get, I'll write it here, Sx. So that would be 0 plus 1 plus 2 plus 3 plus 4, which is 10. Then we need Sy. That would be 0 plus 3 plus 4 plus 7 plus 8, which is 22. Great. Yeah. Next, I should work out what xy is. So, not quite that. I need to actually calculate x times y. So 0 times 0, of course, is 0. And then that will be 3, 8, 21, 32. So now I can get Sxy. 46 is it? Good, 64. Yeah. Now what do I need next in my formula? I need to also know xx, which is the x squared, so that would be 0 squared, 1 squared, 2 squared, 3 squared, 4 squared. So xx is, what is it? 30? Okay, like this. And finally, I also need to know the n. What's the n here? 5. Yeah. So, if you look at the formula for one moment, you see it's n times sxy minus sx times sy over n times sxx minus sx times sx. So, on your calculator, using this formula, tell me what the a is. The formula is also on the last page of your book that you have there. So here are the numbers to use. So I'll double check it on my calculator too. Albert, do you have your calculator? Take it out and calculate. You got an answer? What did you get, Junwei? 2? Yeah. What did you get? 2 as well, yeah? Anyone else? 2 as well? So, A is 2. Okay, and then the B is sy over n minus A times sx over n. So calculate the B now. You got a value? Yeah. .4, is it? Anyone else get an answer? What did you get? 0.4. Yeah. So now we have the equation of this line. Okay. Can I delete this here? Yeah. Okay, let me. Okay, let me just go. We'll do another one maybe. No, actually we'll leave it. I think it's okay. So, for your assignment you'll need to calculate, as part of the assignment you'll need to calculate this line. Okay. Right, now before
How much is A? How much is A?
The A was 2 and the B was 0.4. Did you get that, Malik?
I get 0.8 for the
calculation mistake maybe. Okay. Can I remove this? Yeah. So what I'm going to do now is just make the plot here, the scatter plot for this. Well, actually, before I go on to something new, was there any questions that you had? Probably not, since you weren't in the class last time. But were there any questions from anything so far? Silence means either no because I didn't do it, or yes but I don't want to ask, or other. Or also silence could mean I wasn't listening to your question, I'm very tired. Yeah. Anyway, there's nothing you need to have a look at from the book. Is there? Last lesson you weren't in for. The lesson before that was the scatter plot. That was easy, wasn't it, the scatter plot? Skewness was okay. And I think the only thing with the histogram was one or two of the numbers was wrong, wasn't that in question 2, I said there were 100 TVs, but there were only 99 TVs. Yeah. There hasn't been, I don't think there's any problems. Anyways, look, if you do your work and you discover a problem, you can let me know in the tutorial next week as well. Okay? Right, so let's make the scatter plot here. Insert chart and then scatter plot. Okay? And we'll just put X on X and Y on Y. Okay, let me shrink that down a little bit. Okay. So if you look at this scatter plot, what do you feel about the linear relationship? I mean, do you feel like there's a strong relationship, that it's nearly a perfect straight line, it's almost a perfect straight line, it's not very straight? What do you think? Well, how about if I did something like this? If I said 0, 2, 4, 6, and then 8. This is a perfectly straight line. Yeah. Now, if I start to change them a little bit, so if I said this was 9, this one was 4, this one was 3, this one was 1, and this one was 1. Now it's still, you can still draw the straight line. Let me put it in actually. Come on. But what's different now in this one? It's not quite as straight as the previous one here. And what if I just put in random numbers? 5, 1, 8, 4, 2. I mean, that's a terrible line, right? So we need some way to measure how good the line fits the data. So we know that this one is bad, and we know that this one here is perfect. Not perfect. Perfect. So we need some way to measure how strong the relationship is. We need some way to know if it's a really good fit or a really bad fit. And that's what this lesson's going to be about. How well the data fits. Okay, so write this word down. We're going to have a look at something called correlation. Yeah, I have it here. Yeah, I'll give it to you in a little bit. Maybe you know this word in English already. Does anyone know this word from English? No? Victor or Marcelo? No? Have you heard this word in English before? How would you, if you know it, how could you explain it? Any ideas? No. No one wants to try? Remo?
Is there like a positive relationship between two things are connected, like?
Yeah, connected, good, yeah.
That one can affect the other?
That's it, yeah. So when we use correlation in English, we usually use it to mean some kind of relationship. So for example, I might say, like in business, if I spend more money on advertisement, what should happen to my sales? They should increase. So this means we can say that there's a positive correlation between advertisement money and sales. Yeah. What happens if in business, I don't know, I hire more people? What happens to my profits maybe if I hire more staff? Or if I pay my workers more, what happens to my profits?
Inverse relation.
It probably will go down. It depends on the situation. You know, if you just decide to pay your workers more, but you don't expect them to work more or do more, then your profits will go down. So this is a negative correlation. Yeah. Or I got one. Study hours. As your study hours increase, what should happen to your grade? Increase. So we can say there's a positive correlation between study hour time and grade performance. Okay, so we can use correlation like this. We can we say that we can say X is positively or negatively correlated with Y, and you can use whatever X and Y you want, or plus or minus. So in economics you might say income is positively correlated with quality of life. More income means better quality of life. Something like this. Or in business, advertisement is positively correlated with sales. Yeah. Okay, can I scroll down? You have this English here? Yeah. So this is the worst correlation. There's no relationship here. That's the worst correlation. This is the best, or downwards, this is the best. This is positively correlated, and this one is negatively correlated. In real life, you'll get something like this, in real life. This one here. Yeah. So we use something called the correlation coefficient, or just correlation for short, and we use the letter OR for that. In this picture we say the OR is exactly 1, meaning it's perfect positive correlation, and in this picture we say the OR is -1. In this picture here we'll say the OR is 0. There's no relationship between the X and the Y. No linear relationship. And something like this is actually pretty good. I'd say this is something like, 0.8 as an example. So the OR is a number between -1 and 1. And the endpoints represent a perfect linear relationship at the -1 and the +1. But this is more like real life. And this here is you've done something wrong. Okay, this is no good. It means you've picked two things which have no relationship. This could be how many hours you study, and this could be the temperature of the day. Well, no, there might be a relationship there. Hotter days mean you study less. Let's see. This could be, I don't know, the exports of America. American exports. There is no relationship between how much you study and how much America exports. There shouldn't be a relationship between the two. Okay. So here the relationship, the correlation is 0. Yeah. If actually, let's make some different values here. If I can just open up the wiki page, there's a nice picture on it. Can I scroll down? Yeah. So tell me, in what discipline, in what subject do you expect your graphs to have a high correlation, positive or negative? Yeah, so like for example, in a messy subject like business, if here I have how much you spend on advertisement, and here I have sales. Positive or negative correlation? Positive. But it won't be, it won't be a perfect line. It'll be something like this. This would be an example of something in business. My question is, what subject do you feel would have the best graph for correlation? What do you feel would be the best? I think physics. A subject like physics, where you're performing experiments, I think you'll get very nice graphs. The correlation should be very, very strong. But in something like business and economics, it wouldn't be. Now, I want to show you, and I want you to draw something for me. In the exam, they sometimes give you pictures of scatter plots, and you have to match them up with how much correlation you think they have. So let me give you the graph here in Wikipedia is quite good, actually. Yeah. Now, you can forget about the second row and the third row. How do I zoom? Here it is. That's the loading. Steady. There we go. Full screen. There. Zoom in. You can still see, I hope. These ones here, don't need to write this one down. The correlation is perfect here. This is going down, it's -1. This is also going down, but we still say it's -1. Please don't be confused with the slope, okay? This is nothing to do with the slope. You can see these are all -1. They're all -1 because they are perfect lines going down. These are all +1 because they're perfect lines going up.
What's the correlation of the horizontal one?
Yeah, I think it's math error. There's no value. You shouldn't have this. I wouldn't know what it is. I'm guessing math error on the calculator. You'll probably get something like 0/0.
Maybe there's no relation. You can't have something like.
Yeah, I think.
Does it increase or decrease?
Yeah, no relationship. It's just constant. So we understand this one, yeah? Now this one here is what I was drawing. So you can see this one is 0. Why is that 0? Well, no relationship. It's just random. But can you see here, this one is kind of straight. But this is like my example, 0.8. It's more in a straight line. And then you can see that's perfect, and that one's perfect. Okay. But what's interesting is, this is only linear relationship. In these graphs here, there is a relationship between x and y. There's a clear relationship. This is a circle. This one here, there's a relation. All of these have a relationship, but are any of them a straight line? No. So the correlation is 0. Even though there's some relationship between x and y, the relationship is not a straight line. So all of these shapes have 0. Okay? Oh, it's only for straight lines. Yeah. Now what I want you to draw in your book is the top row. In the exam, what normally happens is they give you 4 pictures and 4 correlations, and you have to match the picture to the correlation. So I'd like you to draw the top row, please. Yeah, you drew that? Beautiful. Great. Okay, can I continue? You have that drawn? Yep. Okay. So the or can be positive or it can be negative. But usually we don't care if it's positive or negative. We don't care if it's positive or negative correlation. We just care about how good a relationship it is. And there's something else we use. Sometimes people use or squared. So what's the smallest or square could be? And what's the biggest? The smallest it could be is... No, 0, smallest. And the biggest it could be is 1. Yeah. But in fact, this or squared has a meaning. It's percentage of explained variance. And if variance is to do with the word vary, or what we talked about in the last class, which was error. So you know that when you have your scatter plot, there's a little bit of error. This or squared is how much is explained. I'll show you what I mean by that in a moment. Can I go on? Yeah. If I look at, for example, this scatter plot, what would we say the or is here?
0.4.
I think it's better than that. Here, let me help. I would say something like 0.8, okay? So what's or squared here? 0.64. Yeah. So then or squared is 64%. So what that means is that this line explains 64% of the variance. I will explain what that means more now in a second.
Actually, like when I was in the high school and asked the teacher the same question, he said like...
For this?
Yeah, you have to give the square on the...
Yeah. We can use both the square and the non-square. Let me explain in more detail what this means. Guys, hold on. If you look at this graph, this is x and this is y. You have a 0 explanation for the relationship between x and y. They just change, and you don't know why they change. You have x, you have y, and you have no idea what the relationship is. They're just different values. So none of the values are explained. But if you draw a straight line through the data, you think, okay, there's some relationship between x and y. A bigger x means a bigger y. But do you know exactly the value of y if you have the value of x? No, you don't. You can have a rough guess. For example, if I say here, this is my x, the line says the y should be here. But where is the y really? Whereas actually, it's here. So there's a little bit of an error. Now, it's only a small error. So this line, we say it has explained 64% of the variation. That it's like saying it's pretty good at explaining the y for the x, but it's not perfect. Now imagine I put in this graph, something like this in blue. I say, it's linear, but it's changing from positive to negative. Maybe it's every season it changes or something. So if I have this graph, like business sales, like maybe in the summer people spend more, and in the winter they spend less, so it goes up, down, up, down, up, down, something like this. Now, for this graph, we can say 100% has been explained. That if you tell me the x, for example here, I can tell you perfectly what the y is. So of course this is what you want, but like I said, in real life this never happens. In real life, anything better than 50% should make you happy. Okay? So if you can explain 50% of the relationship variation, then you are doing a good job.
So if they ask for the error, you get it 100.
Sometimes, yes, I suppose you could do it that way around, yeah, but it's not usually this way. Now, this is important because in the exam, they sometimes ask you to explain what your R squared means. So, for example, if you got an answer like this, R equals 0.8, you could say that's a positive what? Positive correlation, a positive relationship. Or, I think it's nicer if you say, well, R equals 0.8 means R squared equals 0.64, which means the line explains 64% of the variation. There is 1 or 2 marks going in the question for an explanation. A lot of the students say, screw it, I won't write a sentence, it's maths class, I don't want to write a sentence, I don't like English. Fine, then you're losing 2 to 5 marks in your exam. And if you can live with that, I guess I need to live with that. But you really shouldn't throw 2 or 5 marks away just because you don't feel like writing a sentence in a maths exam. Okay? And I'm giving you a template sentence that you could write. So, have you got this sentence down? Yeah? Yeah? Okay, so now that we've talked and explained a bit about correlation, let's look at how to calculate it. Right, so if you want to calculate the correlation, the formula is, let me double check, yes. It's a bit like the b, the slope. We start off with s xy minus, I think this was in the other formula, wasn't it? It was, let me see, where was it? Kind of like this formula. Divided by, and there's a square root here and a square root here. And I think this is sxx minus sx, and here syy minus sy. This is how you can calculate the OR. You have that? Yep. Come this way around. Tell me, do you think this will always be bigger than this? In fact, it will be. Sxx is always bigger than sxsx, and syy is always bigger than sy. But sometimes they might be equal, and then that's a problem, I think. Maybe Malik, when they're horizontal, this is when they're equal, but they should be bigger. If you've got a negative number here, you've made a mistake. It's not possible. It should always be bigger. Okay. Although on the top, this one could be smaller than this one because it could be positive or it could be negative. So that's fine. But on the bottom, these should both be positive numbers. Okay. Can I go to the spreadsheet? Yeah. Where's my spreadsheet on here? Close. Right. So let's 0.5, 1.5, 3.5, 7.5. 7.5. Okay, so what I want you to do to practice is calculate the correlation here for these 5 points. Okay, any answers? Not yet, that's okay. Oh, you got a negative? In the square root? No, impossible. Are you sure? Maybe I got something wrong with my formula. Let me double check. Right. Well, let's calculate the parts together. So the first one, S, X, okay, I'll trust you. S, Y, okay, I'll trust you on that one. S, do we need X, Y? We do. So let me put X, Y here. This one times this one. What did you get? 58, good. Okay, and we need S, XX, and then we also need S, Y, Y. Okay, so we need an XX here. And we need a YY here. An SXX. What did you get for that one? Okay, good. And then SYY? 113.25. Okay, well maybe I got something wrong in my formula. So it should equal, on the top, what did I say was first? SXY, which is, thank you, minus SX times SY. Right, so let's just see what the top is. Minus 137 is fine, yeah. And then we'll look at the two square roots. So the first square root was SXX, which is 30, minus, this is the problem? Okay, I think I know what I forgot in my formula, which I need to fix. I think there needs to be an N here. Yeah. Now I'll double check online. Yeah, okay. I left out my N's. But let me double check that before I start telling you something, and then you memorize it.
No, I think we have it in the exam.
Yeah, don't worry, it's in the formula book. So I'm not expecting memorization here, but I must have typed in something wrong. Now, there's many different ways to write it. This is the thing. In many different ways. What? Ah, my hand! Son of a gun. Alright. N. That fixes everything. Can you add those n's into your formula? N. So does that make the top exactly the same as the other formula? It does. For the edge, the top is the same. Only the bottom is different. You got that? Added the ends in?
No, how much there?
Huh? There's an n in front of the SXY.
No, I mean,
What is the n? In this, here the n is 5 numbers. Okay, let's make those changes. So here I forgot to put in my n. That's the top now. And on the bottom I put in my n. Okay, and then the other one, square root n times syy minus sy times sy. Okay, let's recalculate. So my or should equal the top divided by this square root times this square root. And tell me what you get. We'll see if it matches. No. It shouldn't be. What is going wrong? Ah, my 5 is stupid. Sorry. No! 5 times G3. G3 is...
you forget the 5 in the bottom.
Did I? I put in 4. What an idiot. Right, sorry. 5. And then this one here, I put in 5. Yeah, okay. That's better. 0.98. All right. Good. Right, 0.98. Let's try another one, since that was a disaster. And I'll be extra kind to you. You can get the x, y, x-x and y-y on the screen here. But I'm not going to tell you this part. Okay, so we'll go and we'll go 0 to 4 again, but let's change this, I don't know. Alright, so the first one we'll do the n. What's the n here?
5.
5. Great, you can do the rest. So this is the data here. Let's put a colour on it. This is the data, and this is your calculation, and then these are your sums. So next, Sx, so total of the x's. Sy, total of the y's. Sxy, total of the xy's. Sxx, total the x's. Syy, total the y's. Yy's. Yes. Oh, that's Albert. You got an answer for or? What did you get for or? And can you also get or squared, please? Right, so Sx, sum of the x's, 10. Sy, sum of the y's, 30. Sxy, sum of the xy's, 100. Sum of the xx's, 30, and sum of the yy's, 98. Did you get different answers? 98, no? You're right. How could it possibly be 98? 354.
Yeah.
That's okay. But my or I got is different to yours.
I got the same as you.
Oh, I thought you said a different number. You got 0.95, was it? Yeah, okay. And what's the or squared then?
0.92.
As a percentage, that's about 92%. Whoops. About 92%. So you could say that this linear model, this line, explains 92% of the variation in the data. Having trouble? No? You sure? It's okay? Yeah? Continue? Yeah? Okay, so next now. You don't need to write this part down. You finished the last one, yeah? Yeah. So, here is height, Albert. Here's height in centimeters. And here's weight in centimeter. Kilograms. Kilograms. Okay. Is there a relationship here? Yeah. What type of relationship? Positive or negative? Positive correlation. Strong or weak correlation?
Strong.
I think it's pretty strong. I think you should get, I don't know, it should be pretty strong, I think. So is it right to say that more height causes more weight?
Yeah.
Yeah, I think that's right. Okay. What's on? No? Let's do a business one. So advertisement and sales. What do you think the relationship is? Positive. Please. What do you think the relationship is here? A strong positive correlation. Is it right to say that more advertisement causes more sales? Yeah. Now what if I did something like this here? I put sales here and advertisement here. I plot the data this way. What type of relationship? Well, it's the same, isn't it?
Yeah.
So we can say there's a strong positive correlation. True? Is it right to say that more sales causes more advertisement?
Yeah.
No.
If you
No.
have more sales, we'll do more.
But it's not right to say that having more sales will cause you to spend more on advertisement. If you have more sales, why would you spend more on advertisement? You wouldn't.
To have more sales. Yeah.
So imagine this, I open a business tomorrow and my sales keep increasing. Does that mean I should or will spend more on advertisement? No. If anything, I should spend less on advertisement because I don't need to do anything. I'm getting more sales. Let me give you another example. You all know a windmill. You know, you see them turn in the wind on a windy day. Yeah? Or ice cream sales and temperature. So what do you think the relationship between temperature and ice cream sales are? Positive and probably pretty strong. Now if I swap them, if I put ice cream sales here and temperature here, relationship, positive, correlation. Is it right to say though that sales cause a warmer day?
No.
No, because if it did, everybody in Ireland would buy ice cream to improve the weather. Right?
There might be a relationship.
There is no relationship. There is no relationship.
Something like global warming.
Okay, yeah. All right. Yeah. More ice cream means more farming, which means more global warming. Yeah. But for Ireland, probably not. We're too small. Yeah. Yes. So the reason I'm telling you this is that just because there's a correlation doesn't mean that one causes the other. Okay. I'll do another example here. This one here is how yellow your teeth are. And this one here is how long you live in years. And this can be how yellow your teeth are from 0 to 10. Where 10 means there's no yellow, and 0 means there's no yellow, and 10 means your teeth are perfectly yellow. And what do you think the relationship here is? There's actually a negative relationship, that the more yellow your teeth are, the less you will live. Yeah. So, somebody tell me why we have this relationship. Have a think about it. Now, it's completely wrong to say yellow teeth make you die sooner. But I want you to think about what really is happening here. Have a think, and then if you have an idea, let me know.
What's the yellow?
Huh?
What's the yellow?
How yellow the teeth are, your teeth. So 0 means your teeth are perfectly white, not yellow. And 10 means your teeth are perfectly yellow, no white. Yeah, what's happening here? Any ideas? No ideas? No? No one can think of a reason why there's this relationship. Okay. So, if you smoke more, what happens to your teeth? It turns more yellow, which causes you to live less. So this is an example where there's a third variable that you don't see. Having more yellow teeth means you probably smoke more, and smoking more causes you to die sooner. Yes. So this is an example of a missing relationship. I'll just say there's a missing third variable. That's what's happening here. I'll give you another example, and you can tell me what I am missing. Here is ice cream sales. And here is, we'll go with murder. Yeah, murder rate. And there is a positive relationship. Clearly, ice cream sales does not cause more murders. So tell me what you think might be a missing third variable to explain this relationship. Possibly income, although more income means more ice cream, it should mean less murder. So what could be happening here? So you use your imagination now. What could be happening here?
If you buy ice cream, you don't have money in your pocket.
So you kill someone and take your money, yes.
And if someone comes to steal you and you don't have money.
And then you're dead because you spent it on an ice cream. Yeah. Good, I like it, but not this, I don't think. What
you fighting with your girlfriend?
No, none of this. No. What's happening here is more ice cream sales means the temperature is probably higher.
Yeah.
And in fact, it's shown that in hotter climates and temperature, the murder rate actually goes up.
Like a hobby.
I think it's more like, you know when you see on TV the riots, and it could even be like in riots in France or Spain or whatever. Those tend to happen more on hot summer days. This is true. So
murder is like
huh?
it has to be killed by someone else.
Yeah,
It's
so
not like if you said like death rate.
no, I'm not saying death rate, I'm saying murder. People are angrier when it's hotter, and there's a higher murder rate. Yeah? Now, the reason again I'm saying this is, in the exam, they will say at the end of the question, does this mean there's a relationship between blank and blank, whatever it is. So it depends on the situation. You might have to explain. Okay? So in the exam, because it's a business exam, they'll usually pick a business X and a business Y. So you can try and explain if you feel there is a real relationship or there's some explanation like this. Now, in the exam, you don't get marks for being right or wrong. It's not like you said, for example, about if people buy more ice cream, they have less money, so this means they die when they get robbed. I would still give you a mark for that, okay? It's not about being right or wrong, it's about trying to explain, okay? So again, don't freak out about trying to get the correct explanation here. The important thing is that you attempt to explain it. So your girlfriend example, that would also be fine as well, okay? It's not about being right or wrong, it's about the attempt at explanation, okay?
Can we say that like there is no relation, yeah?
Yeah, now you can also say there's no relation, but you still have to explain why it's correlated. Yeah? So even though there's no relationship between ice cream and murder rate, you still have to explain why the graph is correlated. And one explanation is that there's a missing third variable. Also, another problem is this graph is linear, but it won't be linear forever. Do you think it will increase, stay linear, or decrease later? I think it will decrease. I mean, yeah, more ice cream sales means warmer weather, which means more murder rate, but it won't continue forever until everyone is killing everyone, okay? It's going to flatten out later. So also in the exam they might ask you, is it right to continue this graph and then you have to decide yes or no. And in this example, you'll say no, because the murder rate should decrease. It won't continue on forever because everybody will be dead. So it can't continue on forever. It has to level off. Okay. Now, what I want you to do for the last, actually, few minutes here, I want you to try these. But the people who were missing on Wednesday, I don't want you working on this yet. I want you catching up on what you missed last time. I want you doing, have you got your book here? People who missed Wednesday's class, I want you to do questions 3, 4, 5 on the last worksheet. And then people who were here Wednesday, you can start on the homework from this one. Please note the formula at the back is missing the N. And then Wednesday, people who were asleep, when you finish 2, 3, and 4, then you can start the next worksheet. Okay? This is very important for your assignment. So it's important that you do all of these questions.
Do we get the course worksheet?
For the assignment?
Yeah.
Oh yeah, I'll give it to you when it's time to start. Yeah. Don't worry, I didn't forget about you. How could I possibly forget about you? So seriously, what happened? You were just asleep, or was there anything special? Be honest. You can't make it worse. Yeah, okay. The only way you could make it worse is if you said, I came to school, I was here at 9 o'clock, and I decided, screw Stephen, I'm going to Starbucks. That's the only way you could make it worse.